right? So EEG signals. So they had this thing that you put on your brain, and then they interface that with computers, and they tweet it without actually typing or saying, that the person with that thought about something, and then that was the tweet that went out, right? So that sort of brainwave, brain control interface would be something that's very interesting to look for as well. Um, let's see. Sorry, keep going between this and that. Okay. So next would be your 3D control body parts. You could, so economists, this is not something that's just like science fiction again. Like economists actually predicts that by 2023, the first implant that's 3D printed would have, would happen. It could be a liver transplant or whatever it is. That could happen in 2023. That's not too far, as early as 2023. So you're talking about things that you can print, 3D print, and then use. I don't know how the technology works, or if this is all, science fiction, but there are possibilities to do that in future. So you could biohack and create organs using 3D printers, is what people claim. Lastly, designer babies came up in the earlier panelist talk. So the first, did you know that the first three-parent baby was born in 2016? So essentially, they took the egg from one woman, removed the nucleus from that, and took a donor egg and put the nucleus from that egg into this egg, and had an artificial insemination from the sperm to create this. The reason they did that is not because they wanted a designer baby, because I think the mother had a condition called the Lee syndrome. Essentially, it's a mitochondrial DNA defect or something that they were trying to avoid in the baby, so they had to remove that. So there are possibilities. Apparently, you could go in, change the genetic structure. So that opens up a Pandora's box, right? So, say for instance, I say I don't really like the color of my eyes or whatever it is. Then you can go. Can you actually go in if it's possible? Can you do that? And how ethical that is, and what are the other implications of that? Are we really playing God, as the previous panelist said, and what are the implications of doing that? Because there will be consequences, right? We may not at this point understand or even fathom the kinds of consequences or the kinds of things that we are inviting by doing things like that. But there are all possibilities that you could do now. So these are some of the ways. So I am mostly interested with this context. This is the new area that I'm looking at for research. There are two things that I'm interested in. This is mostly going to be useful or interesting to the media researchers and technology researchers, not as much as the biologists in the room. But I am interested in the two aspects, like I said. One is, I'm really curious when I asked you, like, how many of you would get a biostat? We had a few. I teach a class with 300 students in it, and sometimes I ask them when we talk about these issues, how many of you would, if there was a technology that you could, there's a chip that you can put in your brain, and it would contain all the information that you needed to know. You could upload, download things. It's a little bit risky, but it would, it's something that you can get. It's available in the marketplace. I usually 20 to 25% of the millennials say, yeah, sure, I'll get one. I don't know if they understand the implications or consequences, but the idea is appealing to them. And there's always going to be somebody who's going to go ahead and do it, right, at some point. So those are things that I'm really curious and interested in. So there's lots of media theories and technology theories that talk about adoption of technologies, diffusion of innovations, and the theory of planned behavior, which is essentially how do attitudes influence somebody to behave in certain ways. So using all of these theories, I've created a model, proposing a model here to understand essentially individuals' attitudes towards biohacking and how that would lead to their intentions or willingness to adopt such technologies, and ultimately how it would impact their biohacking behaviors. So um, essentially what I'm predicting, what this model is suggesting is that the more somebody perceives something to be useful, the more likely their attitude towards is going to increase. So similarly, it's easy to use. Then if there's less privacy concerns or the fear that somebody could hack into it or control that information, then these are obvious things as well. Some of those like that perceived risk, ethical, moral concerns, socioeconomic factors, and age as well. So these are some of the aspects that could potentially influence the adoption of it. And keep in mind, I haven't even touched on this whole idea of like the ethics and privacy could in itself be an amazing entire book or a project that you can look into or have a discussion or a panel on, right? Lastly, and I'm running out of time, the next area that I'm really passionate about is the political economy of biohacking. So whatever we do in today's world, right, whether it's technology research, biology research, genetics, whatever it is, we still are within the broader umbrella or the system of capitalism, right? So what's really scary to me is in the same class when I asked them, you know, the 20% of the people that would get those biohacking technologies, I would ask them, well, if it costs a lot of money, um, but you could get it for free if it was preloaded with some ads in it, would you do it? Like half of them would say yes, and half of them like, I have to think about it. So that aspect of capitalism and advertising creeping into this area is what freaks me out as much. Then so because, for lack of a better word, a better system, the what is the saying? Like capitalism is the worst of all, but that's the one we have. I forget all the time. Like it's democracy, maybe that was I'm confused with. But anyway, so it is the political economy, and what I'm more interested in how advertisers are going to use this, and even more importantly, who are the people and companies that are going to be players in this market. You saw Jeff Bezos on this exoskeleton. There's a lot of research happening at big companies like Apple, Google, the big fish, right? So those are the ones that will be jumping into this area. If then we see the same trend that we see in media conglomerates and the way the oligopoly of media business works now. Can we expect to see a similar, control of biological devices by these companies as well? So to wrap up really quickly, there's an open source DIY, do it yourself way of doing these things as well. There are all these venture capitalists and startups investing tons and tons of money in this area and research. So that is something to pay attention to. And then the big tech giants that I talked about to look at how the business, if you want to look at follow the money approach, right, how the business of it is going to impact how these technologies are widely adopted and how they would change the way we live our life. So that's all I got. Thank you.
Our final panelist today is Lucas Niebert, a doctoral candidate in biology at the University of Oregon. Niebert earned his BA in biology chemistry at Willamette University, an MS in soil quality at Wageningen University. Now in the Institute of Ecology and Evolution, his research interests include the role of microorganisms, the role that microorganisms play in evolution. His topic today is hologenomic inheritance. And you made it.
this works here. It takes a little while sometimes. I'm using a virtual Windows machine. Almost. There we go. That's what I want. Well, while this is loading, it's a pleasure to be here. I uh, coming from University of Oregon, and yeah, so I recognize Nikolai. We're colleagues at University of Oregon, but I haven't seen Marie since 10 years ago when I worked with her in her lab as an undergrad lab assistant at OHSU with the Ullman lab. So that's a pleasant surprise. But at any rate, I'm here to talk to you about. Actually, sorry, this is the wrong talk. I'm here to talk to you about the vertical transmission of endophytes and the holobiome. But for some reason, I brought up the wrong talk here. I had several of them open. Let me pull that back down. Should be right here. That's the one. Okay, here we go. Seed is a means of hologenomic inheritance. And so, uh, Nikolai gave a little bit of an overview of what a holobiont is. I'm going to talk more on that and generally the magic of microorganisms. And a symbiont is either of two organisms that live in symbiosis with one another, mutualistically or otherwise, I should say. A lot of people think of symbiosis as something that is always mutualistic, but pathogens are also in symbiosis with their hosts, and you know, it can be a negative interaction. And then there's also the holobiont is kind of a play on the symbiont, in which it's actually the host and associated symbiotic microbes. They can be bacteria or fungi. And as I study plants currently at the U of O, a lot of these slides are going to be about plants and the plant microbiome. And so we have some examples here of the plant microbiome, uh, and you can think of the microorganisms that are very closely associated with the roots as part of the microbiome. And on the very right side, we have arbuscular mycorrhizal fungi, which actually penetrate into the cells and are an extension of the plant root and grow through the soil and exchange nutrients in exchange for the plant's sugars. And uh, there's also plenty of bacteria and fungi as well that live internally in the plant, and they're called endophytes. And that's the main topic of my study. And the collection of genes of the holobiont is known as the hologenome. Here's a figure showing that the human microbiome, in terms of genes, far outnumbers the number of genes that we have as humans. And uh, so in the genes that encompass both the host gene and the entire microbiome represents the hologenome. And I also want to mention, though, it's kind of different than uh, the human genome or any like host gene, is that conceiving these genes as um, not being static and not remaining in the host, at least not yet until we do more genetic engineering in people, but that they're actually moving through us at any time in our life. We have genes from bacteria and to some extent fungi that we inherit at birth, and they might exist with us through time. And some are more transient. And this is some kind of problematic aspect of trying to wrap our head around the hologenome is actually these genes are moving in and out of us throughout a lifetime. And another way to sort of wrap our head around what a holobiont is it helps to think about sort of a continuum of symbiosis. So to give an example, we have very, very tight symbiosis in our bodies right now. Discarding any microorganisms that are associated with us, we actually, as eukaryotes, in addition to fungi and plants and protists, we have these obligate uh, microbes to speak that live inside of our cells that were inherited over 1 billion years ago. And basically, these are our organelles. They're our mitochondria and our chloroplasts. And there's also actually examples of in insects, in aphids, there's a microbe called Buchnera aphidicola, which both the aphid and the microbe are dependent on each other. The aphid is malnourished without it, and the microbe would not exist outside the host. And the microbe exists within the cell. We have other examples of within cell microorganisms. They're living actually inside the cell membrane, free living in the cytoplasm. We have Wolbachia, which is another insect symbiont, and it's not necessarily obligate. It can be there or it cannot, and it wouldn't necessarily the host wouldn't necessarily die. And in some cases it's negative, in some cases it's actually positive. And then we have bacterial endosymbionts of fungi, so bacteria that live inside fungal cells. And then taking a further step back, we have this kind of complex topic of within the host body. So not embedded within our cells, but they're kind of between cells. We have our gut microbiome, and as an example, and also my area of study, which is endophytes. And these microbes indeed live inside our body, but uh, they're not living inside of our cells. They're interacting with them very intimately, but there is a separation. And so here we sort of have an identity crisis, where do we actually draw the line between hosts and symbionts? We have this whole continuum of some living obligately in the cells versus others that we encounter maybe just at some point in our lives. And at one point, do they represent our identity, or are they just visitors? So, uh, also the question we've been talking, holobiont has been used more and more, and the question that ecologists would like to ask is it just kind of a neat metaphor, or is it actually necessary important to help our understanding of ecology, patterns we observe in ecology and evolution? So, going over basic evolution, I'm currently a grad teacher. Brendan Bohannon's class is giving a plenary bit, and he's sitting in the back of the room right there, and we're going over basic evolution right now. And uh, so there's three requirements in evolution. You need variation in traits across the population. You need differential selection on those traits, which you can call fitness. And then you need, importantly, inheritance of traits. And then when we're thinking about it in holobiont terms, you might think of some kind of relationship with that. So uh, similarly, you need variation in microbiome, which contributes to the variation in the traits of a holobiont. Uh, there's microbe-mediated traits that confer differential fitness to the holobiont. Um, and again, thinking of these microbes as sort of these global genes are in the holobiont. And then finally, microbes and their conferred traits are inherited. And this is kind of tricky because there's not a lot of mechanisms out there whereby microbes are inherited, except you see a lot of the times that if you look at the microbiome of a plant versus, platypus, you will see that like a lot of the platypus microbiomes look very similar to each other. Corn, different corn individuals, they have very similar microbiomes. And how does that happen? And there's this notion that, well, one, they could be very efficiently transferred from the environment um, generation, and the other one is vertical transmission. That's what I'm talking about today. Um, right? Browse for a second there. So, and then bringing it back to, is the holobiont theory really necessary? We already have this wonderful theory of coevolution, right? Where we have our cells, our individual cells, and the individual microbes in our cells, and they have their own uh, their own needs in order to survive, their own ways that they achieve fitness. And so, you can just think of it in that like concept that we're all individuals and there's no whole organism. And so, and what you need for that is simply variation in the abilities of hosts to regulate their microbiome. Um, Microbiome regulation affects the host's fitness. So it's sort of like the host has the ability to affect the microbiome, but it's separate from the host. And then finally, that they're sort of genetically inherited. Like the host is able to um, regulate its microbiome in a preferential way, and that is then inherited. Um, so I hope you can sort of see the nuances, but the difference between evolution and biome. And so my PhD dissertation work is on the the fact that microorganisms are inherited in seeds. Actually, as a pretty very common way that microorganisms can be transmitted to the host in the next following generation. Some ways it seems that it's more efficient than other means. There's talk of vertical transmission between human mothers and their infants, but this seems like a somewhat of an evolutionarily conserved phenomenon where we see, there's bacteria that are in between embryo cells and seed. Far right, we have a fungus that, and so uh, these represent an important component of thinking about the holobiont and the hologenome because they actually uh, represent a unit of inheritance of the hologenome. And some questions that arise: well, how efficiently are microbes inherited via the seeds, and does the gain or loss of seedborne microbes affect plant fitness? Um, and there's been studies showing that the efficiency of seedborne transmission, something like, in some cases, 70%. So you see 70% of microbes in one generation represented in the other, and those are seedborne, but usually a little bit less, like, I don't know, 15%. And then in regards to the seed and the inheritance of the polygenome, I started thinking about a model of how do they persist. Um, and sort of running out of time here, so I'm going to speed up a little bit. But you just have to imagine that they have to germinate with the seed and then grow through the plant and then wind up in the seed at the end of the generation and then remain dormant and be replanted again. So uh, seed-borne endophytes, they affect plant fitness. They have a whole bunch of nice traits that affect plant fitness, just like you might have genes affecting plant fitness. And there's beneficial microbes that are seed-borne, just like there's beneficial genes. And there's some pathogenic microbes that hitchhike in the seeds, just like we have negative genes that actually don't contribute well to our fitness. So there's some parallels there. And the last little bit of a applied aspect is a lot of companies are treating the seeds against pathogens, um, seedborne pathogens, because they're pretty visible and well known, but they could be inadvertently removing this seed-borne beneficial microbes, and therefore sort of removing or reducing the hologenome that's seed-borne. And I have some data here. It looks like I want to leave a little more time for discussion, and I just want to move on here. And so future research directions. There's many ways you can think of moving forward with this, but I guess I wanted to just finish with the discussion questions part where sort of when is it fortuitous to use the word holobiome and hologenome instead of describing the host and microbes as separate organisms? And is it just is the hologenome concept useful or simply kind of a metaphorical musing? Does it just feel good, or does it have some kind of explanatory power? So I'll leave it at that.
So we have about 5 minutes. Are there any questions from the audience for our panelists? I'd love to hear them talk to each other a little bit too.
Actually, no, it's actually very interesting because he did mention something that I thought was very interesting. So, the future of biohacking, right? So, you want to talk about a little bit what you just told me?
No, so what I was saying is that all the interesting biohacking strategies that were played was very often between technology that tends to be inert or at least not active or at least not acting on its own self-interest and the human body, right? There's a sense in which my phone will not leave me, will not decide at some point to simply take off, right? And I was saying that what's going to be interesting into the future is to actually, if we are paying attention to this, significant relationship that we have with our microbes, is the extent to which the microbes could become a very interesting way of biohacking literally
Right.
our body, right?
Right. And it just blew my mind because the possibilities. So we were talking about putting inanimate other, RFID chips and things like that in our body. They usually don't change or transform, right? So now if I'm understanding this right, you can put stuff in future in your body that could transform with time and ultimately do things that are maybe not predictable or change and adapt to the environment in some ways as well. So that dynamic nature of it is just whoa. So,
Aren't they doing it already, like taking someone's healthy foods and putting it in a disposable
That's
container?
that's one of the ways, yes. Yeah.
But I think there is a big difference between this. I mean, what I'm seeing and what I really worry about is this complete functionalization of biology. So, we've pretty much damaged the planet, and now we are going into excavating the livings too. That's potentially that's where we're going eventually.
Scary. Yes.
So my comment follows the nuclear hospice. Some of you talked about bioethics or ethics in general. It was really not clear to me what you mean by ethics. There was the usual rhetoric about inevitability. There was no talk about intention. There was no talk about agency. And all I heard, frankly, was a kind of Indo-operationalism. So I actually would like to hear your definition of ethics beyond TANs, if there is one at all, guiding you in your operations.
So I sort of think of myself as being an ethics professor, but I'm equally thinking of myself as staying away of single definitions of what ethics is. I think fundamentally ethics is the domain of value that produces both an explanation and at the same time a series of norms that guide behavior, broadly speaking, where things such as agency, intentionality will be definitely part of that ethics. But I could go on and I say what I think ethics does as a domain. What it does for me here is something slightly different. For me here, what it does is Not as much the ethics, because I wasn't interested in sort of saying a story of value as much as I wanted to say that any kind of ethical theory has very significant assumptions as to how the world is and how the world functions. If it haven't had those assumptions, ethics will not be practicable enough. So it has to be practical. Therefore, it has to be linked to the real world. And I think the ways in which biology, and it's not just biology, I think cognitive sciences have done this 20 years ago, for example, have changed the ways in which we understand ethics. So for me, that was a little bit more the relationship that I was looking for with this discussion of the microbes. And the ways in which, for example, if we can go back to Kant. Kant had a very specific definition as to what the self is and how the self functions within the world. Kant's notion doesn't hold within a relational universe like the one we are seeing right now. So it's not that I'm saying Kant is wrong. I'm simply kind of saying, hey, your ethics, it's disjoint of the ways in which we understand the world. So that was the place where I wanted to find myself. Not necessarily telling people what to do or not what to do, but the ways in which a new view of the world could change the ways in which we also envision changes in the nature of values.
But isn't there an obligation? What I feel is a kind of freewheeling quality about the presentations, aside from Marie-Pierre and Professor Gunga, for instance, in your class. When you present these things, you presented them open to us in this open-ended way. Do you not saturate those questions with some kinds of ethical dilemmas? Do you not present it where we might go and how we might? You seem infatuated by all of this, and I'm wondering about that.
Right.
I'm wondering about the limits as we've opened our.
Part of the constraint here today is about what each person has picked and what
Right.
to
Well,
talk about.
that's not. No, 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 no,
Well,
no, no.
no,
That's
it's
not.
it's
That's not
but
correct.
I want to hear what this
It's not
is.
correct.
We have come to the end of this
Well, okay, but it's not
conversation.
because of time limit. I'm
So
asking a
what
question
I'm
that is of
suggesting
substance.
is that it would be a good thing to continue this
No,
conversation
it's in front of
okay.
me.
Oh,
So,
I could respond to that. So I think you do raise a really important issue of it, and the fact that there are very few people that are seriously dedicating, for instance, their lives to study this and understand this in a way that has much broader implications and all those things in consideration, right? But majority of the people, we live in a world now with alternate facts. Like I don't it's hard to get through the crux of the seriousness of these issues in a broader public way, right? So to me, that is a bigger issue. How do you take something that's so important and serious and make it and present it in a way that people do when they say, yeah, I'll get a implant or whatever, have this broader understanding of what that means. And it's not a one-on-one conversation, right? Somewhere in our education system, in the way we organize our all kinds of things, institutions have failed us in a way that it's not a well-rounded,
the
informed
question I
decision.
asked you was about you and your classroom, your
Yeah.
presentation material.
Okay. Well, I mean, I can't do that in one class. So what I was trying to say.
I'm not asking about a global issue. I'm asking about how you present this material.
Thank you very much for coming.
It's funny that you said we could have had this panel in
So Brendan, Pat Curtin, Brendan Bohan, and Janet Wasco.
Yes, nice to see you.
Roberta is in biology.
Yes, exactly. I did dine in your home.
There it was.
Near Tubman Park. Yeah, exactly.
And
So
so,
let me get my talk.
get yourself all.
And
How that happens.
well, the text
people told me don't touch anything.
Oh, okay.
But yeah,
Before Ted gets started, I should.
yeah, we do have to.
Will they come back?
We do have to. I don't know how to load it.
Okay.
Figure out how to load
Oh, here we go. There's someone here.
He's an artist.
Let me go check first and have him at least go set up to.
Okay. I'll be easy relative to setting up somebody virtually. I'm here, so that's all that matters. Yes, we did get this. I appreciate your service. I was there within
I
25
find,
minutes.
especially with some of the physics, I find it helps so much. Yes, please do.
It would be a little bit weird to sit on here. And then is there a mic or just the lectern mic?
Basically, we'll be taking turns here, I think.
Okay.
So I just got that down in my head.
Oh, okay, good. I won't mess with it then. I'll figure out that too.
Sign under the. Says that's for help here. Oh, sure. Let's have fun. Oh, he's not seeing us.
Dude, are you seeing us?
Here we have the tech.
Oh, he's not seeing us, right?
Hello? Wow, that is. Can you hear us?
Wow, you sound like Darth Vader, Ted.
Yeah. Um. Uh. Are you using the browser? The browser in browser Blue Jeans, or are you using the app? Man, your voice is so creepy from this end. I'm so sorry. Um, I think it's a.
It sounds so gnarly, Ted.
uh, I'm sorry. I think. I don't think it's your mic. I think it's Blue Jeans. If you can disconnect and reconnect. Sorry, if you could disconnect and rejoin the meeting, we might. That'd be great.
Yeah, that's the little guy.
No, I just had to teach this morning, and we drove through the worst weather ever. 5 accidents, but we made it, Lucas and myself.
So
But yeah,
cute.
so I have nothing but just show up. It might have time.
Yeah. For tonight.
Wonderful. Yes, thank you. Tomorrow I fly out to see Ted.
That's what I understand.
So
This is all carefully coordinated.
carefully coordinated.
Okay. Oh, that's still bad.
All right, we're still getting the odd audio from your end. Um, is that a USB headset? if I give you my cell phone number, could you call me? Because my phone number is 971-201-1796. If you could hear on it sounds like the devil. That's right. That's right. So, have any other you say you're using the app, oh, okay. Right. Yeah, yeah. Do you by any chance? Okay. What's your and you're welcome. That is you're gonna share that. You know, can we try maybe doing it maybe for an iPad that we could use for this? Let's try your cell phone. So can we go ahead and disconnect this, and I think it's gonna prompt you to download an app, and it's just oh dude. Alrighty, thank you much. Thank you. Bye. So is it the what is whose file is this? Is it the What is Life 2017? What is Life 2017? I'm guessing.
Well done, yes. And there's what's PowerPoint, a PPS, and a PPT. If the PPT will work, I prefer that one. I did it on a Mac, so I wanted to make sure. If you don't mind, I'll zoom through the slides to make sure you show up.
And where's the little guy that was here?
I don't know. That was just it was open when I showed up.
Where's where's the other one?
Oh, the one that was in there was taken by the woman who presented first on the last panel.
Where is she? She took my clickers receiver. Do you know what she looks like? Yeah, that thing.
I'll go take a look.
we're not getting our clicker back. I'm gonna have to go get a different clicker. But if you open your slides,
Where is it? Oh, this is the whole folder, isn't it?
yeah. Do you want to switch the view?
Yeah, switch the view.
Sure,
Thank
sure.
you. Sorry, I was once a
That's fine.
PC person that once you go Mac, you cannot go back. Right?
I'll do details
I'm
instead.
actually PC, so I would have known.
Ah. All right, now go toggle off the video conferencing.
I thought it was actually under your name. Oh, that looks pretty good.
Show it there. What do I do? Maybe that doesn't matter. I just wanted to make sure they come through.
Okay, that's what's not working because someone ran off with our
Oh,
receiver,
I have
and
one in
that's
my
what is
bag.
getting a new one.
I have my own. If we can.
Yeah.
I'll pull it up.
It's right here.
And so,
And just toggle this up on the screen.
I'll go get it on the screen.
as you're walking out,
Maybe somebody else. Looks
Oh,
good to me. What do you think?
I could be Renee Hobbs for today. It's one of those names that can apply to anyone. Huh?
Does that mean I get to be Brenda?
You could if you'd like. Over there.
Okay, thank you for coming today. If you'll give us just another minute, we're working through a few technical difficulties, and we hope to have them straightened out shortly, but we will get going in about one more minute, so thank you.
Technical opportunities.
yeah, so I would assume I'll be your final liaison because Melissa won't be here, and then for problem solving. I'll get a little more
And that one's tomorrow.
So let's get the other presentation started now.
Sure, that's this guy.
Okay.
Are we? All right.
You're like super tall. So
No. I'm going first.
you're going first?
Can I pace like a caged animal with it? Does that work?
Yes,
I may
absolutely.
just do that.
Okay, that
Try to
works.
adjust it.
So we're just going to start with Brenda?
Yes, I think so.
Okay.
Do you want me to full screen or? Yes, please.
Okay, thank you all for coming today. We're still working our way through some technical issues, but we're going to reverse the order on the program. So this is the third plenary of the What is Life conference on ethics in biology. We have two very distinguished guests, one who will be joining us via telepresence if technology allows. We've asked each to speak for about 25 minutes, then we'll take questions afterwards. I'm going to be a little ruthless about time so that you all can catch the bus. I know no one wants to miss the bus. So first up today is going to be Brendan Bohannon, who's a biology professor at the University of Oregon. And his work applies ecological and evolutionary theory to the world of microbes. And for fans like myself of Sand County Almanac, he was the Aldo Leopold Leadership Fellow at Stanford's Woods Institute for the Environment. So I turn it over to Brendan.
Thank you very much. I almost started pushing this, like Melissa McCarthy as Sean Spicer, but maybe I'll try this instead. All right, can everyone hear me? Wonderful. Thank you. I'd like to start by thanking Jer and Janet for the opportunity to speak today. As the person who introduced me just mentioned, I'm a biologist, specifically a microbiologist. And so what I thought I'd talk about today were a couple aspects of microbiology that touch on the themes of the conference that Jeremy Janet put together, and that build on some of the talks that were in the previous session, if you attended the previous roundtable session. So specifically what I'd like to talk about is a question that's sort of central to biology for hundreds of years, and really central to human thought in general, which is this idea of what does it mean for us to be human? What makes us human? And for hundreds of years, this debate has really focused on this idea that you can think of what makes us human as some combination of nature and nurture, this term that was first, I think, proposed by Francis Galton. And in its extremes, what this means is that we can think of us as humans as either robots, sort of programmed by our intrinsic characteristics to be a certain way, so the nature extreme, or that we're a clean slate, the tabula rasa of John Locke, right, on which our experiences are written as our life unfolds. Right? These two extremes of nature and nurture. And as a biologist, this nature-nurture distinction has really been translated into a distinction between genes and the environment. So it's a question about how our biological nature as humans is determined by some combination of the genes we receive from our parents and the environment that we experience through the course of our lives. Right? So genes and environment. Now, up to a few years ago, scientists, biologists in particular, have felt like this distinction between nature and nurture, or genes and environment, really this is getting old. We really understand how this works, and this is a concept that should be retired. And we know that most traits, most biological characteristics of humans really are a combination. They come from an interaction between both nature and nurture, and you really can't separate out the effects of genes from the effects of environment. So for example, if you take one of my most obvious characteristics, it's my sort of ridiculous size, right? The human height is really clearly a product of both genes and environment. My parents were very tall, so I inherited my height essentially from them. But I'm also very big because I grew up in an environment where my nutrition was very good when I was young. Right? So it took both environment and genes to produce the giant scientist you see before you. Right? And this is true for a lot of different biological characteristics. So we felt like, as scientists, that we had solved this, essentially. It was no longer a useful distinction. But recently, this idea of nature versus nurture has become popular again because we've realized, as biologists, that we've been missing something about our nature as humans. And what we've been missing is that we are not just genes and environment, but we're also this thing called the microbiome. And those of you who were in the previous session got a little introduction from Nikolai and from Lucas as to what we mean by microbiome. And so the microbiome is the collection of little tiny forms of life, bacteria and fungi and other small things that inhabit our bodies, that live on our surfaces and inside our bodies. And collectively we call this the human microbiome. And they're everywhere. So they're in your mouth, right? There's a very rich community of things that lives in your mouth. It's very important for our health. Find them on our skin, millimeters deep into the covering of our body. There's little tiny forms of life. And most notably, you find them in our gut, where we have a very rich and abundant collection of microbes that live inside us. And this collective that we call the microbiome is really essential for our health, and it's also extraordinarily abundant. If you think about the distribution of types of cells across the human body, most of what we are is actually microbial. We actually have more bacterial cells, more fungal cells together than we have human cells. So in that sense, we're more microbial than we are human. And when we usually think about microbes in the human body, what do you think about? Most people think about disease or about pathogens. But the vast majority of the microbes that we find associated with our bodies are not only not pathogenic, but they're essential for our physiological functioning and our survival as humans. So here's one example. The microbes in our guts are responsible for a number of different metabolic functions. So there's foods we can digest only because we have this particular microbes in our guts. They synthesize vitamins for us. They ferment particular substrates we couldn't otherwise have access to. They produce somewhere between 7 to 10% of our energy budget comes from these other forms of life that live inside us. They also have a number of functions that provide protection. So the microbes live in our guts, prevent certain pathogens from invading. They stimulate our immune system. As children, they helped our tissues develop into healthy forms. So in this way, they provide a number of really important benefits to our bodies. And one of the things that's most remarkable, I think, about this is that these benefits can be transferred along with the microbes. So there's examples where biologists have taken, for example, the microbiomes from a mouse that's genetically predisposed to be obese, moved it into a lean mouse, and that mouse then became obese. Or vice versa. You can take the microbes from a skinny mouse, move them into a fat mouse, and make it skinny. Right? So you can transfer the characteristics that are conferred to these hosts by their microbiome by moving the microbiome. And not only do these microbes associated with our bodies help us to digest particular foods, they can also change the way they can influence when we make decisions about eating, so when we feel full or when we feel hungry. And they can even, there's some evidence, they can even drive cravings for particular foods. So they could even alter our behavior in terms of the diet that we choose. And this connection between the microbiome and the brain is one that's received a lot of attention recently and has spawned an entire field of research called the gut-brain axis. And this is an area of biology that's focused on trying to understand the relationships between the microbes in the gut and the functioning of our brain. And there's really strong evidence now that the microbes in your gut can influence behavior, can influence cognition. This has been shown in animal models, for example. And that the brain can influence the gut as well, that through the physiological responses to stress, for example, you can influence the composition of the gut microbiota. So essentially, the gut microbiota can be a kind of memory, or it can store the experiences that a host has through changes in its composition. So something I'll get back to in just a bit. All right. And like the other properties of the microbiome that I mentioned earlier, the effect of the microbiome on behavior can be transferred, along with transferring the microbiome. So you could take the gut microbiome of a mouse that's genetically predisposed to be shy, move that into one that tends to be adventurous, and you can make that mouse shy by moving the microbiome. So again, this is all biology, all research that's really been published just in the last 10 years or so that gets at the details of how intimately we are associated with these other forms of life that live in us and on us. And so there's this possibility that something as central to how we think of ourselves as humans, as our behavior, could be in some degree under the control of something that we think of as alien, as bacteria and other microorganisms, which I think raises some really interesting philosophical questions that hopefully we can get to at the end of my talk. All right, so I've given you a little overview of what it means to have a microbiome, and what I mean by the kind of post-microbiome world that we're in now, this perception that the human body is more than just a collection of human cells. So how do we think of this? Is the microbiome kind of a part of our nature? Is it part of nurture? Is it something that we receive from our environment? Is it genes? Is it environment? Is it something totally different? So there's been a number of efforts to try to work the microbiome into past thinking about what it means to be human. I want to talk about that for a few minutes, and then at the end I'll talk about, when I have time, talk about why any of you should care about this, why this might be interesting. All right, so in some ways, microbiome acts kind of like our genes. In fact, it does this to a degree where some biologists refer to the microbiome as our second genome. And Lucas mentioned this briefly in his talk as well. We've seen this, people have talked about our other genome. Lucas showed this figure earlier that shows that the human microbiome, in terms of its genes, is like a genome that's orders of magnitude larger than our own, and that codes in it properties that our own genomes don't code for, so the ability to use particular foods, for example. So in that way, it's kind of like genes. We also receive our initial microbiome from our mothers, sort of like the transfer of genes from parent to offspring. This starts to occur in the womb and then accelerates through the process of birth. And then, like our genes, the composition of our microbiome tends to be more similar to other people that we're closely related to. So this graph depicts what's called dissimilarity. So this is the degree of dissimilarity on average between pairs of microbiomes across people. So the smaller the bars, the more similar the microbiomes are. And the smaller bars are from twins, monozygotic, that's MZ, and dizygotic twins. So twins tend to have very similar microbiomes. After the twins, the next biggest bars are for relationships between parents and twins. So twins tend to be similar to their mothers and their fathers in terms of their microbiomes. And the biggest bars, the most dissimilar microbiomes, are between twins and unrelated people. Right? So we tend to have microbiomes like our families. So in that sense, sort of like genes. But there's aspects of the microbiome that aren't gene-like, that are more environment-like. So for example, our microbiome can change in a very dynamic way over time, and that can be in response to changes in our environment. So here's a diagram from a recent paper from Eric Alm's group. This is very complicated. Let me walk you through it, and I'll show you what the take-home message is. So across the top, that diagram depicts the composition of one person's gut microbiome over time, over about a year. So on the x-axis there, 0 through 300 is the number of days. Different colors represent different kinds of microbes in the gut. And the width of the bars, the width of these little ribbons, is meant to represent the abundance of that particular type of microbe. And so you can see over this year, there was great fluctuations in the number and type of microbes over time. So much bigger fluctuations than we have in our genomes, which are much more static. And what's interesting is you could link some of these shifts to changes in the environment. Except, for example, there's a big shift around year 100 or day 100 here. And this bottom graph just shows these changes in more detail, higher resolution. And you also see this big change around day 100. And that happened to be a 3-week period that this subject took a trip to Europe and went backpacking.
Testing.
So I wonder if study abroad makes a difference in people, and here you go. Right? Changes their microbiome, right? All right? So much more dynamic and much more responsive to the environment than our genes might be. So our microbiome also is, you can see patterns in its composition when environments converge as well. So I just showed you an example of changing environments. This is a paper that came out about 2 weeks ago that's, I think, really fascinating. What this paper described was a study by the European Space Agency of 6 astronauts, depicted here, who they're training to go on a Mars mission in the future. So they put them in a simulator of a Mars housing unit, basically a sort of crappy apartment that they built somewhere near Zurich, I think, in Quonset hut, right? And they stuck them in there for over 500 days. And they measured all kinds of aspects of their physiology and their performance. But one of the things that they measured was, again, the dissimilarity of their gut microbiomes. And that's what's on the y-axis of this graph. And this is time in the simulator, so how long they were there. And so what you see is there's this decline in dissimilarity, or to put it in clearer English, the microbiomes of the astronauts become more similar the longer they stay together in this housing unit. So in that sense, our microbiome is very responsive to changes in the environment when environments converge. So very much not like our genomes. So it's kind of like genes, kind of like environment, but then it's also kind of really different as well, something different from genes and environment. So one of the things that makes it really different is our microbiome extends beyond our physical boundaries. So most people don't like to think about this. But right now you are generating, I'd like to think of it as a cloud of your microbiome, kind of biological aura that each of you have. It's your microbes being shed from your body. And we know this for a fact because my group did a study just the other side of this building, in U of O's architecture facility, where we put a number of human subjects in a room and we let them hang out for 8 hours and we just measured the cloud that they generated, which was substantial. Within an hour and a half, they made a clean room look like a human, just from the cloud we're generating, right? So this is different than environment, different than genes. It's something kind of qualitatively different. And so in addition to this, our microbiome can also be transmitted to unrelated individuals, right? So we're related to the idea that we're producing a cloud. So right now, as you're sitting together, not only are you shedding parts of your microbiome, but you're sharing them, wittingly or unwittingly, with your neighbors, right? Which raises some interesting questions, I think, about responsibility and ethics and agency. We can talk about in a bit. Right? So your auras are overlapping. All right, so this is starting to encourage biologists to think differently about the nature of humans, about what makes us human. So one model that's kind of emerging from this is building on this idea of nature and nurture, or genes and environment, and describing humans as gems, right? That we are the product of our genes, our environmental experiences, and our microbiome, singly and in interaction, right? So what makes us each uniquely human is a combination of these 3 sets of factors. why should you care about this? I mean, it's intrinsically kind of interesting to realize that we are, in a way, much more different than we might have been led to believe we are as humans. But I think there's also some bigger implications of this that are worth thinking about. So one is that this does, I think, end up being a very different view of humans than the conventional view that we have. In part, what this view shows us is that we're much more dynamic in terms of our natures and much more diffuse in terms of our boundaries. And so it calls into question what it means to be an individual, right? If we have these fuzzy boundaries and we're sharing aspects of ourselves, wittingly or unwittingly, with other people. And I also think that this, in an interesting way, kind of blurs the distinctions between the physical and the cultural. And these are new thoughts I've had over the last couple of weeks. It's a little scary for me to talk about this as a hard-nosed scientist, but I think this is really cool, this possibility. Let me walk you through what I mean by this particular speculation. So imagine, as I mentioned, that our experiences are recorded in some way, at least in the short term, in our microbiome. That the experiences we have in our daily lives alter in some way, quantitatively, qualitatively, the composition of the microbes that are associated with our body. So that's been observed in humans and in animal models. Now imagine also that our microbiome can be shared, can be transmitted from individual to individual, which we also know to be true. Right? Then all of a sudden that opens up the possibility that our experiences can be transmitted among us in a very material and kind of bizarre way, right? That we are producing a cloud of information about ourselves that we are sharing with each other. I mean, in a way, it's sort of like cultural transmission, like sharing ideas with people, but it's very material in the sense that this is happening through the distribution of the microbes that are associated with our bodies. And I think this is an interesting idea worth talking more about. All right. How am I doing in time? Oh, I may end early. That's unknown for me to do that. All right, well, a little more time for discussion. So one more reason. Oh, there's just a picture of what I'm imagining is happening right now in this room that we're sitting here in. Transmitting among us our recorded history through our microbiomes. So finally, another reason why I think this is interesting is this new view of humans is starting to impact a number of areas of human biology, but specifically human medicine. When I talk to my physician colleagues, they're describing to me how the practice of medicine is starting to change. So in one way, it's changing in a large part. In large part is through the use, it's through the way that physicians think about their job, especially infectious disease doctors. So in the past, the dominant metaphor for physicians was a series of war metaphors. Our body was a battleground. And the purpose of a physician was to help us wage war against other things, creatures that were not ourselves, microbes in particular. But now that view is really changing, and the metaphor that is starting to get some traction in infectious disease is thinking about the human body like it's a national park, right? Like we're a collection of organisms that has to be managed, right? And our health is the product of that diversity, as opposed to the body being a battleground in which war is waged. All right. So, there's a picture of that. The old view and the new view. All right, so let me just end there, and let me just thank a few people that made this talk possible. So Jeremy Schwartz and Janet Wasco, of course, for the opportunity to talk today. My colleagues Nikolai Morar, Karen Gilman, David Relman, who's through conversations with them have generated some of these ideas. And then I would be remiss if I didn't thank my microbiome, which made all this possible. All right, thank you.
Okay, at the beginning of the session, when I said that we would hold all questions until the very end, I lied to you. So what we're going to do is go ahead and take questions now for Brendan, and that will allow our tech people to do a little magic.
So the question was whether there are particular microbiomes that might be more attractive to other humans, that might, facilitate interactions among humans. And we don't know that yet. There's no evidence yet that that's true, but it seems like it's reasonable. What there is evidence for, though, is that there are microbiomes that tend to be more attractive or more repellent to other creatures, specifically mosquitoes. There's a lot of effort, as you can imagine, trying to figure out what makes some of us really, really attractive to mosquitoes and some of us not. And there is evidence that at least some of that has to do with the microbiome of our skin and the chemicals that are being generated. We don't know if that's true for humans, but it is for insects and humans. Yeah. Oh, thank you.
So can trauma affect the microbiome, and can trauma be passed to other people in families or in cultures? Can you have collective trauma that's recorded through the microbiome?
That's a great question. I don't know. I mean, physical trauma can be, but whether non-physical trauma can be transmitted, I don't know if anyone has. I haven't seen a published paper that has suggested that. But as I think about it, I may have heard of studies that are in progress right now that are asking this question. Yeah, it's a great question.
So I'm assuming, I don't know that this be true, it's just sort of a stereotype that a lot of the biome is in our guts. Right. And then you talked about how it's affecting our eating behavior, and I'm wondering if this is basically a feedback loop, that if I flood my system with cake and sugar, that it's killing off part of the biome that can't handle this unhealthy diet, but it's leaving the ones that crave sugar. In other words, that through your diet, you're changing your biome in which way now it will want you to keep eating that way.
Again, a great question, and we don't have a definitive answer to that. And we know that the pieces are true. We know that diet can affect the structure of your microbiome, and different microbiomes of different composition differentially affect things like cravings for food. But the whole feedback loop hasn't been shown. But it seems reasonable that could be the case.
Thank you. You mentioned a little bit of this, and I'm curious whether or not you've heard of this in conversations about the microbiome. But earlier this morning, we were talking about media as being objects that have life in their own, and I'm wondering if there's conversation about microbiome entities as having a life of their own and their own agency and their own advocacy and that sort of sense. Sorry, I don't mean to actually stump you. I'm just curious.
What a cool question. I'm certainly not among biologists, but I don't know if that's, that may not be true outside of biology. Nikolai, where are you? What do you think? Are there people talking about microbiomes having their own agency? I mean, other than you?
It really depends what people think of agency and what kind of criteria do you set up for agency. But if you have minimal criteria for agency, then definitely you can see something like that, which is amazing to assume that single cell organisms could have something like agency. I mean, but philosophers are struggling with that problem. Yeah.
I'm having fun. We'll do this all afternoon, unless you tell me when to stop. So.
Fascinating. Thank you so much. What role do pheromones play in this mix?
Oh.
We're talking about chemistry.
Yeah. I don't know. Yeah. I mean, that's the. I'll try not to make it that a long-winded no. Yeah. I don't know. I certainly don't know what the relationship might be. I mean, other than, okay, I lied. I will make it a long-winded no. I mean, other than pheromones have been shown to impact the interactions among humans, and if we physically interact, we have more opportunity for exchanging members of our microbiome. So there's certainly reasonable there could be connections. But yeah, something. Yeah. Two more, according to the boss.
I have two questions. As far as I remember your lecture, you gave us as an example the two mice, and you said they changed from shy to adventurous. That is the only proof you gave us for what you said here. Can't you be a little bit, or shouldn't you be a little bit more careful about your transfer? because that was the only example you gave. Be more careful about the transfer. That is the first question and remark. Second thing, in your summary you said it's a combination of genes, environment, and microbiology. Can you weight these three factors?
Wow, this audience is scary good. All right. So the first question, I certainly could be more specific. Whether I should have been or not, that's an open question. But the best examples for the transfer of traits from the microbiome are from the model animal literature, primarily from the mouse literature. And there are a number of examples. And so the one I alluded to there, in cartoon form, have been a number of studies where they've taken mice that are genetically predisposed to being shy or adventurous, and there's a formal definition of this with the maze that was on my slide there, that half of the maze is exposed, and so some mice will explore that exposed part of the maze and some will not, and this seems to be related to their genotype. But you can override that by transferring the microbiome, and so you treat the mice with antibiotics, you give them an implant of feces from mice that have the opposite behavioral characteristics, and then you run them through the maze. For how long do they have? Oh, so they've only, these have been short-term studies, so we don't know about long-term how long those effects are. But one thing that's interesting, though, I did not believe these studies at first until they showed that that transfer of traits to function, that there had to be a functioning vagus nerve. If they cut the nerve in the mice, then you couldn't get this transfer of behavior. So there's some kind of signaling is happening. Chemical signaling, neurotransmitter from the gut to the brain. And so, I'm not aware of any really long-term studies, how long this lasts. Weeks, basically. Yeah, weeks, basically. Yeah. And so that's so on the human side, there's a number of studies that have shown correlations between the composition of the gut and particular behavioral states or behavioral disorders. And there's a huge industry now in trying to figure out if these correlations are spurious or real, and what the mechanisms might be that underlie, for example, correlations between the gut microbiome and schizophrenia or autism or even depression. Yeah. Are we running out of time?
We're running out of time.
Okay. Please find me. I love talking about microbiomes. And thank you.
Obviously, a lot of questions, and we may have time at the end to come back, so please hang on to those questions. Right now, I understand that Ted Toadvine is ready to join us, so we will hope that technology works. He used to be with us here at Oregon until very recently, when he became the director of the Rock Ethics Institute at Penn State. His work centers on contemporary continental philosophy, and he's been instrumental in developing ecophenomenology. And today I'm going to kind of guess from the title of his talk that we're going to hear more about his work examining the eschatological imaginary of environmentalism. We'll see if that happens. Ted?
Great. Thank you for that introduction, and my thanks to Jeremy and Janet for organizing this event, and for everyone working behind the scenes, especially Erica and the others who've helped me sort out our technical difficulties in getting connected. I hope that you're able to hear me. I can't hear you, so I'm operating on faith until I receive word otherwise. Our culture is obsessed with imagining the end of the world, repeatedly and in endless variation, as any trip to the bookstore or box office will easily demonstrate. Apocalyptic narratives are not new, of course. They may be as old as civilization itself, and probably exist in some form in every culture. But secular doomsday fiction is more recent, with Mary Shelley's 1826 novel The Last Man usually considered the first major example. Critics hated Shelley's novel at the time, and it was soon forgotten, but the genre gained wide popularity in the 1890s that has continued to the present. At the turn of the 20th century, most doomsday scenarios imagined that humankind would be wiped out by natural causes, plagues, earthquakes, floods, giant storms, and so on. But since the First World War, most have imagined us destroying ourselves, usually in wars with technologically advanced weapons. Since the 1960s, in the wake of Rachel Carson's Silent Spring, our fictional visions of the end of the world have been increasingly inspired by anthropogenic ecological disasters. And with the end of the Cold War, these seem to have displaced nuclear catastrophe as our favorite doomsday scenario, with the currently popular subgenre, cli-fi, as the latest flavor. A long list of recent films might begin with Mad Max, Waterworld, The Day After Tomorrow, Elysium, Snowpiercer, Into the Storm, Interstellar, and many other films surely come to mind. Why do we take so much pleasure in these doomsday scenarios that we return to them again and again for yet another variation on civilization's collapse? The answer is undoubtedly complicated and layered. There may be a bit of schadenfreude at work, repressed hostility or misanthropy finding an outlet, or some righteous sense of retribution when the obligatory deniers get their told you so moment. But we also identify with the typically ragtag band of survivors, the ones who want to start civilization over with a clean slate and finally get it right, as they rediscover true community in the face of overwhelming odds, much like the real-life disaster communities that Rebecca Solnit describes in A Paradise Built in Hell. Suddenly, our idiosyncratic skills and training, our unique contribution to the survival of the group and the species, our personal memories of what came before take on a magnified importance if we are, indeed, one of the last humans left alive to rebuild the world. Or, at another level, perhaps, as Warren Wegar puts it, stories of the world's end are something like Grimm's Tales for grown-ups, therapeutically building our self-confidence so that we can face our fears when the real thing finally comes along. Now, so far, I have been referring to dystopian fiction, but actual predictions of ecological disaster also share in the appeal of the apocalyptic narrative. The accumulating biotoxins of Silent Spring, the population bomb, the hole in the ozone layer, biodiversity collapse, genetic engineering gone awry, and so on. In fact, this narrative might be essential to environmentalism's efforts to save the world, and the religious overtones here are not irrelevant. My favorite recent example is from journalist Bill McKibben, who has said in numerous interviews that mining the remaining bitumen from Alberta's tar sands would mean, quote, game over for the planet, unquote. McKibben attributes this line to climate scientist James Hansen, even though Hansen's own published phrase was actually game over for the climate. There are two distinct points to recognize here. First, environmental prophecies and eco-dystopian fiction share a common eschatological narrative with roots in shared cultural sources, and they have fed and borrowed from each other to the point where they can no longer rigorously be distinguished. I will call this the eco-eschatological narrative. Second, whether presented as fact or fiction, such narratives are phantasms, fables that we tell ourselves about the future that reflect our investments and anxieties in the present, and that consequently construct our current identities and institutions. I'm thinking here of a similar point made by Jacques Derrida at a colloquium on nuclear criticism 5 years before the opening of the Berlin Wall, where he characterizes the prospect of total nuclear war as a phantasm of remainderless destruction. By naming nuclear war a phantasm, Derrida was not at all denying the reality of stockpiled weaponry, nor the plausibility that this weaponry might be deployed with catastrophic consequences. His point was rather that such a war is fabulously textual, not only because the weapons themselves rely on codes and texts of all sorts, and because the strategies of deterrence are themselves textual games, but most importantly because total nuclear war has never yet taken place. In Derrida's words, quote, it has existence only by means of what is said of it, and only where it is talked about, unquote. In other words, nuclear catastrophe is a tale that we tell ourselves, and nevertheless, or precisely for this reason, it affects a positive construction of present reality, so that all of human society is marked by it directly or indirectly, leading to what Derrida in 1984 could call the general institution of the nuclear age. From Derrida's point of view, the fact that nuclear catastrophe is fabulously textual means that humanists, as experts on discourses and texts, are particularly responsible for thinking it through. As he writes, quote, "The terrifying reality of nuclear conflict can only be the signified referent, never the real referent, past or present, of a discourse or a text, at least today. And that gives us to think the today, the presence of this present, in and through this fabulous textuality." Now, my claim is that ecological disaster, including climate collapse, is fabulously textual in precisely this sense. Turning our attention, as humanists, philosophers, and media scholars, to eco-eschatology as a phantasm implies no skepticism, then, about the very real dangers that we face. Instead, it may be the only responsible way to think the present, insofar as the present is constructed through our fables about the future. That is, we must grasp how our thinking of the ecological present is shaped by eco-eschatological narratives. One interesting characteristic implication of the eco-eschatological narrative is its suspension of the present between a geologically deep past and an indefinitely distant future. I have already mentioned Mary Shelley's 1826 novel, The Last Man, as the first major work of secular eschatological fiction. Set in the late 21st century and putatively based on ancient prophetic writings, the novel tells the tale of the destruction of the human race by a global plague, leaving the last survivor, based autobiographically on Shelley herself, to wander the world alone. It is hardly coincidental that Shelley's novel appeared just as biologists were coming to accept Georges Cuvier's evidence, based on reconstruction of the fossilized skeletons of such creatures as mammoths and mastodons, that the world was once populated with creatures that had subsequently gone extinct. Cuvier intended these findings to burst the limits of time, in his phrase, just as scientific genius had burst the limits of space by providing a window into the former world, as he called it, a world prior to all human history that he believed had been catastrophically destroyed. Surely, if a natural catastrophe could drive so many other species to extinction and bring their entire world to an abrupt end, then the same could be imagined for our species. Our world must be equally precarious and finite, and our days on Earth similarly numbered. This construction of our present as suspended between prehistorical catastrophe and anticipated extinction continues to shape contemporary discussions of climate collapse, as we see, for example, in astrophysicist Neil deGrasse Tyson's remarks on the National Geographic television series Cosmos. So I'm quoting here from deGrasse Tyson. He says, "We're dumping carbon dioxide into the atmosphere at a rate the Earth hasn't seen since the great climate catastrophes of the past, the ones that led to mass extinctions. We just can't seem to break our addiction to the kinds of fuel that will bring back a climate last seen by the dinosaurs, a climate that will drown our coastal cities and wreak havoc on the environment and our ability to feed ourselves. The dinosaurs never saw that asteroid coming. What's our excuse?" End of the quote. As a more concrete example of what I'm calling the temporal suspension of the present, consider current efforts toward global sustainability that extrapolate from deep past trends to predict and manage far future scenarios, thereby tacitly assuming that our responsibility toward future generations is to sustain the world in a state that as much as possible resembles our present. One example would be ongoing efforts to establish permanent repositories for radioactive waste, which must avoid human intrusion and environmental degradation on the scale of tens of thousands or even millions of years. The field of nuclear semiotics emerged from the efforts of the Human Interference Task Force, convened by the U.S. Department of Energy in the 1980s, with the charge of devising a warning system to dissuade future generations from tampering with repositories of toxic waste for at least the next 10,000 years. roughly twice the length of written human history. Interestingly, the task force included speculative fiction authors alongside linguists, anthropologists, and natural scientists. Today, the Greenland Analog Project studies the deep history of ice sheets on Greenland's western coast to design the first operational geological repository for high-level radioactive waste, scheduled to open in Finland within the next decade. In this case, the effort is to ensure that a human and geological situation far in the future is sustained according to standards and expectations projected today. A second well-known example would be the economic practice of discounting the future to assess how much we should spend today to limit the future effects of climate change. According to recent predictions, even if we stop emitting greenhouse gases immediately, we will already have changed the climate for the next 2,000 years. But if we calculate the future growth of the world's economy on the basis of past trends, then the people of the future will be increasingly richer than we are today. How much should we ask the relatively poorer people of today to sacrifice for the relatively richer people of tomorrow? The answer will vary depending on the discount rate, the rate that economists choose to apply, similar to money market interest rates that track what investors are willing to pay today for a certain level of future benefits. My point is that policy decisions and resource allocations being made today on an international scale rely on what I am calling the temporal suspension of the present between the deep past and the far future. The suspension is a temporal fermata, a pause or interruption of the unfurling duration of the present that holds it projectively immobilized between a never-present past and a distant future. In other words, this suspension commits us to more than a mere anticipation of future events. It restructures our very experience of the singular present by silhouetting it against a background of geological eternity. So let me take a moment to tie things together a bit. First, I've suggested that our obsession with the end of the world, in the form of the eco-eschatological narrative that frames speculative fiction as well as environmental prediction, is a phantasm that reflects our desires and anxieties in the present, and that it leaves its mark, directly or indirectly, on our individual and collective identities, institutions, and sense of the world here and now. Second, I have proposed that this phantasm has a history, that it develops in parallel with the emerging conception of deep time, our awareness of an ancient geological past that precedes us opens our imaginations to an indefinitely distant future after us. And third, I have offered some contemporary examples of efforts to calculate and manage the distant future on the basis of the deep past. These examples tacitly embody an approach to time that is inseparable from the eco-eschatological narrative. That is, this conception of time lends our end-of-the-world fantasies their seductive force and ubiquity, even as, in return, these fantasies serve to perpetuate and reify this historically specific conception of time. My conviction is that these 3 points together raise some profound philosophical questions concerning how we understand the world, time, and responsibility. I turn now to a brief consideration of what I find troubling with this picture, and then offer the barest hint for where we might start in formulating an alternative. First, our efforts to calculate and manage the future by extrapolating from the past are an example of what Jean-Luc Nancy calls the equivalence of catastrophes. To see what he means by this, let us first recognize that there's no such thing today as a purely natural disaster. Every disaster, whatever its underlying cause, is inextricably natural, technological, social, economic, and political. Nancy is writing specifically about the Fukushima nuclear disaster, but many have said similar things, for instance, about Hurricane Katrina's landing on the Gulf Coast. The entanglement of our disasters is just the obverse of the complex and ever-deepening interdependence and interconnection of all of these systems: ecological, economic, techno-scientific, sociopolitical, cultural, logical, and so on. Globalization is precisely the process of this ever-deepening interdependence, which Nancy terms the eco-technical. Now, in order for these systems to become dependent on each other, their processes and terms must necessarily be amenable to conversion, translation, substitution, and exchange across these linked domains. As Marx already pointed out, money serves as a general equivalent, since every cost and benefit can be translated into monetary terms. Nancy's claim is that ecotechniques has generalized this notion of equivalence even further, so that, in his words, the regime of general equivalence henceforth virtually absorbs, well beyond the monetary or financial sphere, but thanks to it, and with regard to it, all of the spheres of existence of humans, and along with them, all things that exist. This is characterized, Nancy says, by a limitless interchangeability of forces, products, agents or actors, meanings or values. Now, if this general equivalence makes greater interdependence of all of our systems possible, then it is the reason why our catastrophes are uncontainable in their effects. But more than this, it is the general equivalence itself that is catastrophic, insofar as it inspires a proliferation of means and ends that are ultimately oriented toward no final end, no ultimate goal other than their own continued expansion and proliferation. If any and every end can be exchanged or substituted for every other, and if all ends are interdependently bound within a system that treats them only as interchangeable for other means or ends, the no ultimate end orients the global eco-technical system as such. It is this loss of any ultimate sense or direction that Nancy will call the end of the world. What takes the place of this final end is precisely our constant awareness of the possibility of our own self-destruction. As Gunther Anders writes, quote, "Today, since the apocalypse is technically possible and even likely, it stands alone before us. No one believes anymore that a kingdom of God will follow it, not even the most Christian of Christians." End of the quote. Once he recognizes that the regime of general equivalence has implications for how we relate to time and to the future, and the examples that I proposed above, the planning of nuclear waste repositories and economic discounting of future climate costs, illustrate this point perfectly. The absence of any end or goal for our eco-technical interdependencies, apart from their own self-perpetuation, traps us in a cycle of planning and management of the future in general, although this future is itself characterized by no end or goal beyond sustaining further eco-technical proliferation. Furthermore, the extrapolation of the past to calculate the future demonstrates the sway of general equivalence in our understanding of time, since each chronological present moment is substitutable for every other. As an example of technological interdependence, Nancy refers to, quote, "the determination of an atomic time independent of earthly time and necessary for the worldwide synchronization required by the many digital activities of communication, calculation, exchange, and so forth," unquote. But this eco-technical innovation takes on eco-eschatological implications once it rewrites our very relationship to past, present, and future. As Nancy puts this, quote, "No culture has lived as our modern culture has, in the endless accumulation of archives and expectations. No culture has made present the past and the future to the point of removing the present from its own passage," unquote. The alternative here is to recognize the non-equivalence of the singularities, the absolutely unique and non-substitutable events and moments that compose our everyday experience, and thereby to deepen our respect for the present. In Nancy's words again, quote, "What would be decisive then would be to think in the present and to think the present, no longer the end of ends to come, or even a felicitous dispersion of ends, but the present as the element of the near at hand, unquote. Since the aim here is to respect the non-equivalence of the present, we might call this a proposal for ontological or temporal justice. In other words, justice requires respecting the non-substitutability of the present, and this involves breaking the fermata that holds each moment indefinitely suspended along a continuum of geologically extended time. I'm not suggesting that deepening our respect for the present relieves us of the responsibility to plan, to anticipate the consequences of our actions, and above all, to consider the singularity of all those, human and otherwise, whose existence has been put in jeopardy by the juggernaut of eco-technical globalization. Temporal justice only makes sense alongside environmental justice. As Derrida has insisted on many occasions, the incalculability of the to come does not eliminate the need for calculation. But Derrida is right to point out that there is an absolute interruption between what our calculations can predict and the uncertainty of the events to come, and the ethical moment of decision lies in that interruption. To program the future based on calculations, as global sustainability has attempted to do, forecloses our responsibility toward the future as well as the present. It is precisely an ethical failure to respect the true monstrousness of the future. Yet this asks more of us than simply recognizing that the future will inevitably exceed whatever our eco-eschatological imaginaries project. It also concerns the way that these fantasies of the future, by lodging a temporal fermata over the present, foreclose our engagement with this world here and now. One danger that such foreclosure introduces is the likelihood of an autoimmunitary response, by which our own efforts to manage the incalculable precisely bring about the worst. The Cold War provides plenty of illustrations of how this logic works. Our contemporary eco-eschatological narrative emerged within the context of the Cold War and perpetuates certain features of its logic, as can be seen explicitly in Rachel Carson's Silent Spring, which was published in the weeks running up to the 1962 Cuban Missile Crisis. Just as the phantasmic character of nuclear destruction anticipates and informs our current eco-apocalyptic obsessions, so do its strategies of deterrence prepare the way for game theoretical modeling in international climate policy. As an example of how such efforts to calculate the future hinge on and fail to manage the incalculable, allow me to share with you one hair-raising example from documents declassified by the U.S. National Security Agency in 2013. On July 24, 1961, a B-52 bomber carrying two 4-megaton nuclear bombs broke up in midair and crashed near Greensboro, North Carolina. Luckily, each of the bombs had 6 safety mechanisms to prevent detonation. Unluckily, in the case of one of the bombs, 5 of these safety mechanisms did not work, and the documents confirm that a single low-voltage switch was the only thing that prevented detonation. According to the bomb disposal expert who was on the scene, each bomb had more than 250 times the explosive power of the Hiroshima bomb, which means more explosive power than all of the munitions, conventional and nuclear, that have ever been detonated on our planet combined. He also said in an interview in 2011, quoting the bomb disposal expert now, that, quote, "As far as I'm concerned, we came damn close to having a Bay of North Carolina. The nuclear explosion would have completely changed the eastern seaboard if it had gone off," unquote. Now, since I was born on the eastern seaboard after 1961, it seems fair to say that my existence might also have hinged on this single low-voltage switch. This is a truly insane example, but it is not the only one, and I encourage you to Google military nuclear accidents to get the full picture of what autoimmunitary logic looks like. But let me just point out that schemes for geoengineering as a response to climate collapse and these options are certainly being developed in certain quarters today, are even more frightening. Such scenarios carry us beyond an isolated nuclear explosion, and not only because they escape all hope, calculability in terms of their possible effects. They are truly catastrophic in terms of the ultimate reach of substitutability and equivalence that they take for granted, since they show no hesitation about exchanging the world that we have for a world that we fantastically project. This returns us finally to our apocalyptic vision of the world, which approaches everything within the world and the very sense of the world itself against a background of absolute contingency or nothingness, vulnerable to total destruction. By threatening things with the specter of their own annihilation, and therefore silhouetting them against the screen of nothingness, we force their presentation into self-identity, positivity, immanence. They either fully are or fully are not. But, as Merleau-Ponty already points out, this framing is a denaturing of the thing. Quoting Merleau-Ponty, is not thinking the thing against the background of nothingness a double error with regard to the thing and with regard to nothingness? And by silhouetting it against nothingness, do we not completely denature the thing? Are not the identity, the positivity, the plenitude of the thing reduced to what they signify in the context in which experience reaches them quite insufficient to define our openness upon something? End of the quote from Merleau-Ponty. To this I would add, from Nancy, quote, destruction takes place in the world and not vice versa, which is why Nancy enjoins us, quote, to learn to stop dreaming of the end, to stop justifying it. We need to take our leave of the romantic historical mode of thinking that promises an apotheosis or an apocalypse, or both, one in the other, and instead to rediscover the resistance of existence itself as spacing and permanent revolution. Unquote. This requires not a better architecture of the future, a building of ever more vivid eco-eschatological narratives of apocalypse, but a deepening of our exposure to and within the present. Thank you.
Able to hear us at all?
Yes, I can hear you. Can you hear me?
Yes, we can. So I think we have achieved something here, which means I can turn it over to questions from the audience.
Excellent.
I found your analogy between the nuclear Armageddon scenario and the eco-Armageddon scenario very interesting. But I think there is a very interesting and critical difference. As far as I remember, and I was born in 1939, so I do remember that time, there was no denial of the nuclear danger, except maybe some kind of psychological denial because it was too awful to consider. But now we have denial of global warming and climate change based on ignorance, which is promoted consciously and maliciously by corporate greed. So I think that's quite a difference.
Yes, I agree with you. I do think that that is a significant difference. I don't think it was not my intention, of course, to suggest that the structure of the nuclear apocalypticism and of environmental apocalypticism is exactly parallel. And in one way, of course, everyone knew that nuclear bombs had been created for one purpose, which is for us to wreak destruction on each other. And yet, another interesting difference between the two is that in the case of our ecological apocalypticism, we typically think this in terms of something that creeps up on us slowly, something that we thought was beneficial until we were just a little bit too far along, until we had already crossed over the brink. So I'm thinking about the many movies in which we believe we have cured cancer, only to discover that in fact we've infected ourselves with some, biological agent that will lead to the destruction of the human race. And so there's a kind of sense of a slow creeping and of a kind of ignorant rushing headlong until one is over the edge of the cliff and in free fall. And that seems to me to be, in general, something quite different from what we saw in the case of the concerns about the Cold War. And so my point was simply that we should be thinking about the historical progression of these different apocalyptic conceptions and thinking about what they reflect back to us about our own anxieties and our own ways of understanding the present, since even though we present them to ourselves as fantasies of the future, they're ultimately about our anxieties here and now.
Okay, thank you very much. Another question.
So just continuing this line of thought for a moment, I really first want to say how much I enjoyed your talk and how much I appreciate it. I think we do have other examples of things that people know that are weaponized. Peter Sloterdijk in Terror from the Air, for instance, talks about the weaponization even of the air. And I think with various genetic engineering technologies, we can say the same. So I wonder if you could address this militarization and weaponization of everything in the world that we not only took for granted, but which nurtured us and upon which we were absolutely dependent.
Yes, it's a good point. And I'm not quite sure how. So I entirely agree with you that we're certainly at the point now where we're creating nano weapons. I was having a conversation about nano biometrics that are being introduced under the guise of being made available to athletes, so they can ingest something with biometric trackers that will report back to them or to their coach all of the fine changes in their bodies while they're in the process of going through their training workouts to compete, say, in the Olympics. But of course, one realizes right away that the more obvious use for such trackers will be to use them to train soldiers, right? To use them in combat situations, or even as more direct, immediate weapons. So it isn't clear to me how that. I certainly think that when Nancy is talking about the development of this catastrophe of interchangeability, it's precisely the fact that we treat everything as substitutable and translatable that allows us to build precisely these kinds of innovations. And so there's a sense in which it relies on the same kind of homogenization of everything that exists that I'm saying occurs also in our relationship to past and future, with a kind of homogenization of time. So I do believe that these things are related, but haven't really thought through exactly how the kind of weaponization that you're describing would fit into the overall picture. It's a very good point. Thank you.
Okay, thank you very much. We're running shorter on time now because of the bus leaving. So what I'd like to do at this point is thank both of our speakers today very much for some very provocative thoughts and ways of looking at the world. So please, a last round of applause for both of them.
Thank you.
Thank you very much, and thank you, Pat, especially. We are ready to leave the building and go wander about in a beautiful garden. A couple of things. First, I'm going to have Jer tell you what to do when you get there, and then I'm going to follow up.
Hi, everyone. So we've got a bus for all of us to be able to get on, and it'll be outside here. But first, I want to let everyone know we have some refreshments. We have some nice tea and some Japanese cookies. Yeah, everyone needs a little bit of, a little yes. And so those will be available to you. And so please feel free to take those with you. And in terms of details, when we arrive at the site, there'll be two ways of getting to the garden. And so one way of getting to the garden, if you have a hard time walking up hills, there'll be a shuttle after we get off the bus that takes 15 people at a time, and that will be able to take anyone that has any problems with their back or legs up to the garden. And then for everyone that would like a longer stroll up to the garden, there's a phenomenal walk just right up to the garden itself. And so I just want to make sure, are there any questions or concerns? Other than that, please enjoy the refreshments, and we will meet you at the bus. Thank you so much for everybody, and thank you again.
Hey folks, just a reminder to take all your belongings with you when you go.